Hi, I'm Kathy Welder from Dartmouth College. Today I'd like to spend a few minutes talking to you about desired learning outcomes and give you some strategies regarding how to begin writing your own. By the end of this presentation, you should be better able to describe Bloom's taxonomy of cognitive skills. You should be able to describe Fink's taxonomy of significant learning and construct and critique desired learning outcomes. I'm sure many of you are familiar with Bloom's taxonomy that describes cognitive skills in a pyramid from lower-level tasks to higher-level tasks. When thinking about creating desired learning outcomes from students, we are asking, can the student, and starting at the bottom of the pyramid, remember? Can they recall facts and basic concepts? Can they memorize things and repeat the information that's been stated to them? We also want to know if students understand. Can they explain ideas or concepts? This might include discussing, identifying, and recognizing. Can the students apply information in a new setting? For example, if in the notes I give them a reaction of 1 propanol and I ask them on an exam to carry out the exact same reaction on 1 butanol and they tell me they have never ever seen anything like it, they are not applying the information learned to a new setting. Can students analyze? Draw connections among ideas. I often ask students to create their own summary sheets. While the textbook is divided by functional groups and the reactivity of those functional groups, I encourage them to make other connections. Can they identify oxidizers? Can they group reactions that form carbon-carbon bonds? How about recognizing reagents that are typically used as bases? These all fit under the concepts of analyze. Can the student evaluate? For example, if I gave a reaction sequence and told the students that the sequence did not give the product that is shown and asked them why not, they might have some decisions to make. They're going to need to argue, defend, support, critique. Perhaps one of the steps required an SN2 reaction on a tertiary halide. Or perhaps there was an organometallic reagent present but also acidic protons that would prevent the reaction from going as written. Can the student create? I often think about a multi-step synthesis here. Can they start with small molecules and design an acceptable synthesis of a larger molecule? When creating, there's often multiple correct pathways. In addition to cognitive skills, we might want to consider the major categories of significant learning proposed by D. Fink. What types of knowledge do we want students to gain? Fink says one of the important features of his taxonomy is that it is not hierarchical, but rather relational and even interactive. The various kinds of learning are synergistic. You don't have to give up one kind of learning to achieve another. Foundational knowledge provides basic understanding that is necessary for other kinds of learning. Application learning allows other kinds of learning to become useful. For integration, the act of making new connections gives learners intellectual power. Human dimension learning informs students about the human significance of what they are learning. When students care about something, then they have the energy they need for learning more about it and making it a part of their lives. Without the energy for learning, nothing significant happens. Metacognition enables students to continue learning in the future and to do so with greater effectiveness. So when creating desired learning outcomes, we'll want to consider the cognitive level of learning. We'll also want to consider the types of knowledge. We haven't yet talked about the scope of desired learning outcomes. Some desired learning outcomes will be written at a course level. They're broad, they're overarching, there's only a few per course. What do you want them to know 5 years from now from your course material? And there are aligned topic level learning outcomes as well. They're more specific, there's going to be several per topic, and they're aligned with the course level learning outcomes. When creating desired learning outcomes, I usually start with at the end of the course, or before exam 1, or 5 years from now, students should be able to. Those goals should convey relevance and usefulness. They should be observable and measurable. They should use everyday language and minimize technical jargon. The idea here is that at the beginning of a course, a student should be able to look at your desired learning outcomes and have some understanding of what it is they're going to learn in the course. The learning outcomes should use descriptive verbs. We'll want to avoid understand, and I'll show you why in just a minute. Desired learning outcomes should be aligned with the level of learning that you expect of students. I'd like you to pause the video for a minute to evaluate this statement. By the end of class, students should understand the reaction of alcohols with HX. Think about what you might think as a professor and what your students might think that this desired learning outcome means. Can you think of a better way to phrase this desired learning outcome? Avoiding the use of understand? Here's my attempt. By the end of class, students should be able to draw the products of the reaction of secondary or tertiary alcohols with HX. Provide a complete electron-pushing mechanism and a reaction energy diagram that shows the relative energies and structures of starting materials, transition states, intermediates, and products. Explain why this reaction doesn't work well for methyl or primary alcohols. If I use the word understand, the students may think all they need to do is draw the product of the reaction. I do use Bloom's taxonomy to help me write better learning outcomes. To be able to write good learning outcomes, it's nice to have a list of verbs that can be used. This is one example of a list of verbs that will be provided to you that shows the various levels of Bloom's taxonomy and some verbs that correspond with those levels. You might notice that this is the wording for the original taxonomy, whereas the pyramid I showed was for the revised taxonomy. To help you get started writing your own desired learning outcomes, it might be helpful to see those written by someone else. Here's an example from my course. As a course level learning outcome, I want students to be able to synthesize molecules from smaller organic molecules. For my class, if they need to use organometallic reagents, they have to be able to synthesize those. A topic-level synthetic outcome could be specified such as, after completing Chapter 19, which is our aldehyde and ketone chapter, students should be able to synthesize phosphorus ylides from alkyl halides, and synthesize alkenes using the Wittig reaction of a phosphorus ylide with an aldehyde or ketone. You'll notice that this is very specific. Students should be able to look over the entire list of desired learning outcomes and determine for themselves which topics need review before an exam. As I write topic-level learning outcomes, I consider the audience, behavior, and condition, A, B's, and C's. I don't very often include a degree of mastery, but you can. For example, after completing Chapter 19, that's the condition. Perhaps before Exam 1, or at the end of the course, or 5 years from now. Who? Students. Students should be able to do something. You need a verb. Here, it's synthesize. These are the desired learning outcomes that I include for my Organic 2 lecture course. Chapters 16 through 24 cover the standard organic functional groups for an Organic 2 course, but do not include the bioorganic topics that are often included at the end of my course. I want students to be able to draw mechanisms, provide products or missing reagents for reactions, fill in missing reagents in a sequence of reactions. I want them to be able to do both large and small synthetic problems, and I'd like them to be able to interpret spectra. At this point, you might be asking, where do I begin? You can start with a list of someone else's goals, objectives, or outcomes and modify them. You could start with end-of-chapter summaries that are often provided in textbooks by the author of the textbook. You might look at your old exams and unpack one of your own exam questions. What is it that you were trying to determine if students could do when you asked that question? And another great starting point is taking the Learning Goals Inventory that's provided by the authors of the Learning Assessment Techniques book. You can find that online. In small groups, we're going to write at least one course-level learning outcome and at least one aligned topic-level desired learning outcome. The suggested area for your focus would be that of your small group. Consider cognitive level, types of learning, and scope. I'd like to acknowledge the learning design team at Dartmouth, Adrian, Aaron, Adam, and Scott, and the staff at the Dartmouth Center for the Advancement of Learning, Cindy and Prue. I hope that you will find many of these references available and helpful to you.